Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slade. A reminder to how to participate live if you would like to. You can call the Wahsa studio at 1-800-465-7144 or 737-4017, and you can ask me questions if you'd like. You can listen through the radio at 91.9 FM or through the television at Bell Rescue Channel 972. You can always join me live through the Zoom link. Then you can see the recording as well as ask questions. The link is available through me, your teacher, and also your DEC. Our schedule is such that our classes are on Monday through Thursday from 11 till 12 in the morning. And today is our last day of week 3 of our 9-week course. Monday is Family Day for us folks in Ontario, so we will not be having class. We'll resume classes on Tuesday, February the 22nd. What work to submit for marking? The support questions, those marked with a pencil icon, are not for marking. You decide which ones of those and how many of them to do. If you're understanding a concept, feel free to skip questions if you don't need the practice. If you need more practice, let me know and I can send you some more practice. The answers are in the back of the booklet, so check your work. However, mistakes have been found in the answers fairly consistently. So if anything doesn't line up, please let me know and I can make corrections to help you. Don't assume that you're wrong. The book could be wrong. The key questions, the ones marked with a key icon, are the ones to submit for marking. So please do all of those questions and show all of your work, your steps, and your thinking so that I can give you credit for all of your understanding and you don't lose marks just because you make a calculation error or are missing part of something. If all the work that you give me means that I can give you more marks. How to submit your work for marking. There's 3 methods. The first is to scan and send your work in electronically. So scan your completed work through the iPhone's Notes app or the Android Google Drive app. If you need help to do that, please let me know and I can help you. And then you can send it through email to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca. Or you can send it through Facebook Messenger to bslate.wahsa. The second method is to drop it off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We're the big red building next to the post office, and we have a small white mailbox next to our side entrance. As we are currently working remotely, it may take me a couple days to get your work, but as soon as I get it, I'll mark it and get it back to you as quickly as I can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax 1-800-463-7852. If you have any questions or concerns, please contact me. I'm here to help. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can message me on Facebook at bslate.wahsa. You can call and leave a message for me at the main office at 807-737-1488 or toll free 1-800-667-3703. My office hours are Monday through Friday from 8 a.m. to 2 p.m. and I'll get back to you as soon as I can. Connecting with me through social media can be really useful. So on Facebook and YouTube, both my name is bslate.wahsa there. All of our radio Zoom classes are recorded and uploaded shortly after airing, and you can access them through YouTube, and I share them on Facebook, so you can find them there as well. I also have short videos explaining common errors and confusing concepts on my YouTube channel, so that's a great place to access if you're struggling with something, to go check it out there first. If there's anything you'd like me to explain and have it up there, you can let me know and I can make a video for that as well. Math is very, very visual, so accessing the replays or the live Zoom video is really going to set you up for most success. So please try to tap into those so that you can see what's going on and how I'm organizing information. If you don't have access to a computer, but you'd like a copy of the videos, please let me know and I can send you a USB key. Right, we're on day 12 of our course, and today is a Throwback Thursday. We're going to look at lessons 6 through 8, as well as a little bit back at Unit 1. So a quick reminder why we're reviewing already. We're just finishing our 3rd week. We're a third of the way through our 9-week course, so we still have some time to our exam. So why we're reviewing now? Research done by Herman Ebbinghaus in 1885 found that we forget things really, really quickly, and we lose a lot of information. We don't retain things really quite quickly. So forgetting curve is part of this. It shows us that after one day, we've lost almost 30% of our understanding or remembering of something. Our retention has gone down by 30%. And so very rapidly in just a week, we're down to 40% of remembering what we have done. So if we don't review, we don't touch back on concepts, then in a week, we'll only remember 40% of what we did this week. So that doesn't really set you up for success. However, it was also found that if you return to this information, then your forgetting curve slows down. You don't forget things as quickly, you remember them longer, and you don't need to refresh as often over time, because if you refresh when you first learn something, then it's going to become more easy to retain over long periods of time. So we're going to touch back on Thursdays to check in with what we've already learned, so that when it's time for the exam and we're wrapping up, the information won't feel so far away. We'll be able to remember it. Hopefully it will be more familiar. But first, we're going to activate our brain with some mental math. As we say every day, many of us experienced mad minutes when we were growing up, and they were really negative experiences. They didn't help us learn our facts. They didn't help us understand arithmetic. They were just drill and kill memorization, and you either were successful or you weren't. So instead of doing that, we are focusing on developing strategies that use our brain, that use information that we have and we know, that can transfer into multiple situations. So today's example is 123 take away 59. Subtraction is something that many folks struggle with, and many people make the same mistakes over again. So having more than just the algorithm, more than just borrowing, is really, really useful. So we're going to count back in groups instead of starting at 123 and counting back by ones to 59, we're going to count back in jumps, in friendly jumps. So we're starting at 123, and to count back, I'm going to jump by tens. So going 10 back from 123, I get 113. And then if I jump back by another 10, I'm at 103. And if I jump back by another 10, I'm at 93. And if I jump back another 10, I'm at 83. And if I jump back another 10, I'm at 73. So we can see 10, 10, 10, 10, 10. I've jumped back 50 in groups of 10. So that was really accessible for me. And now I still need to go back 9 more. So I'm going to first, because from 73, I can't just jump back 9 to a number that is easy. I'm going to go in parts to make it make sense. So I'm going to jump back 3 to get me to 70. And then now I need to jump back another 6. At this point, if I wanted to count back by ones, I could, if that was more accessible for me. I'm just going to jump back by 6, because that's fine. I'm fine with that, to 64. But I could go from 70 to 69, 68, 67, 66, 65, 64. And that would work too. Using my fingers to count back to keep track of what I'm subtracting. But instead of doing all 59 that way, jumping off these big parts that were more accessible first made it a lot easier. You also could, from 73, just count back 9. That would be fine too. Whatever works for you really is what's fine. So it's just another strategy, another tool to use. So 123 take away 59 is 64. Okay. All right, let's recap what we have learned so far in this course. So far, In lesson 1, that was transformations of quadratic functions. Lesson 2 was polynomials and factoring. 3 was solving and graphing quadratic equations. Lesson 4 was exponent laws. And lesson 5 were simple exponential equations. So what we did in the first 2 weeks. This past week, we have added lesson 6, which was simple interest in linear growth. Lesson 7, which was compound interest and exponential growth. And lesson 8, which was the compound interest formula. That is the new things that we've done this week. All right, let's look at the highlights of what we did. First, we're going to focus on the new stuff that we did this week, and then just do a quick reminder of what we were doing previously in Unit 1. So lesson 6 highlights for simple interest in linear growth. Simple interest is both an arithmetic sequence and linear growth, where the pattern increases or decreases at a constant rate, the same speed, the same amount. We use the formula I equals PRT, where I is your interest earned in dollars, your P is your principal amount, how much you start with in dollars, your R is your interest rate as the percent as a decimal, and your T is time in years. We can also find your final amount is equal to your principal plus your interest. So then you can find your principal or interest depending on what information you have. All right, lesson 7 highlights. This is compound interest and exponential growth. So compound interest grows exponentially. The pattern increases and decreases at a constant ratio. So it's really fast growth or action. The formula that we use is A equals P times 1 plus R over N, all to the exponent NT, where A is our final amount, P is our principal, both in dollars, R is our interest rate as a decimal, T is our time in years, and N is your number of compound periods. Remember, this formula is different in your booklet, but if you go back to lesson 7 video, I explain why I use this formula instead and how they are connected. We can find the interest by doing our amount to take away our principal, and we can find our interest amount then. Okay. Lesson 8 highlights compound interest formula. So here we're dissecting compound interest problems and figuring out what we were trying to find. So we would always need to have compound in the problem in order to know that we were talking about compound interest. We must identify what information is given and what we're being asked to find. So when we're finding the principal, we need to rearrange the formula using algebra to isolate for P. When we're finding the interest rate, we need to use the nth root to isolate for R. We're finding the time length T, we need to use guess and check to force the bases to be the same. Then components can be set as equal in order to isolate for T. So the nth root and the guess and check model were a little bit new and a little bit different than just rearranging for algebra. So if you need a reminder of what that is, go back to lesson 8, the video, and spend some time there with that. All right, so then a quick recap of Unit 1. So lesson 1 is the transformation of quadratics, where y equals a times x minus h, all to the exponent 2 plus k, where a tells us the opening direction of the parabola, h tells us the horizontal shift, and k tells us the vertical shift. The polynomials and factoring lesson, we have expand, where it means that we're multiplying according to the distributive law, and factoring means that we're finding the two binomials that result in the trinomial product. Lesson 3, solving and graphing quadratics. So solving a quadratic means that what values of x result in y equals 0, and we're looking at our zeros or our x-intercepts. Lesson 4, exponent laws. Remember that multiplication law is that when you have the same base, you add your exponents. Division law is when you have the same base, you subtract your exponents. The power law is that you multiply your exponents. Zero exponent means that your answer is equal to 1, and a negative exponent means that you have the reciprocal of your base. Again, this is a very just quick, brief reminder. If you need more time with those things, go back to the video on lesson 4 and spend more time there. And finally, lesson 5 was simple exponential equations. Exponential growth is exponential change is very, very fast. So increase or decrease really, really quickly. And we talked about either growth or decay. All right, so what we're going to spend our time today with is we're going to do some mixed practice. So I've taken some questions and that are not in your IEL booklet. These are new questions that are similar, that cover the same topics, but I've taken these questions and I've mixed them up so that we get a bunch of questions that could cover any topic from lesson 1 through 8. And we are going to do the questions. So we're going to look at the questions and figure out what tools that we need, which of those topics that we just covered we're going to be using, and answer those questions. And like, we don't know that, oh, this question is definitely an exponent question because I've only been looking at exponents. Our life has everything that we need mixed up, and we need to figure out what tools we have in order to solve those problems. So that's how we're focusing today. All right, so question 1. You are creating a computer model of a skateboarder jumping off a ramp for a video game. The path of the skateboarders is modeled by the relation h equals negative 0.85 times t squared plus 2, where h is the skateboarder's height above the ground in meters and t is the time in seconds. How far from the ground will the skateboarder be after 5 seconds? Sorry, after 0.5 seconds, my bad. So with this sort of question, it's a lot of information. I like to draw myself a sketch. It does not need to be perfect. This is just for me visualizing what is going on. So I'm comparing time to height. So time is my horizontal axis and height is my vertical axis. And the path of the skateboard has a relation that has a squared in it. So I know this is going to be a parabola because at my t is squared and my highest degree is 2. So that means that I'm having a parabola I know it's quadratic. So it doesn't really matter exactly. I can think of, okay, if I'm jumping off of a ramp, I'm going to be not at 0 in my height. I'm going to be somewhere. I'm going to go up and then I'm going to go down in that parabola shape. We can visualize that's sort of how things move. Okay, so I know that this is generally what my shape is. And I have to figure out what my question is now asking. How far from the ground will the skateboarder be after 0.5 seconds? So at 0.5 seconds, and it doesn't matter. I'm just thinking, okay, it's going to be somewhere between 0 and the ground, I think. I'm going to figure out how high the skateboarder is. So that's saying that my time is 0.5 seconds. So all I need to do is substitute my time into my equation to figure out my height, right? Height equals negative 0.85 t squared plus 2. So if I know that my t is 0.5, I can just substitute that in. So negative 0.85 times 0.5 squared plus 2. And then I'm just going to calculate that on my calculator. I'm just going to put that in and I get 1.7875 meters. So now I can look and see if that answers my question, if that number answers my question. How far from the ground will the skateboarder be after 5 seconds? So the skateboarder be 1.79 meters, just going to round, off the ground. So this number does answer that question. This tells me the height is 1.79, and that's how far they're off the ground. And there we go, we've answered the question. All right, so then part B, how long will the skateboarder be in the air? So again, I'm just going to reproduce my quick sketch so that I remember what it is that I'm generally doing. Okay, so how long will the skateboarder be in the air? Well, the skateboarder lands here when the height is 0. So I'm trying to figure out how long this t is. I'm trying to figure out what time it happens that they land on the ground so that they're at height 0. So I'm looking for when h is equal to 0, what is my t equal to? So again, I take my equation, h equals negative 0.85 t squared plus 2. But here, this time, my h is 0, that's what I know. So I'm substituting 0 in for h, and then I'm solving for my t. In this case, I only have t squared, so I don't need to factor in order to find my, I don't need to factor to solve for t. I can just isolate my t and take the square root. If I had t squared plus something times t, then I would need to factor, but in this case, I don't have it, so that's a little bit simpler. All right, so in order to isolate for t, I'm just going to do some algebra. So I'm going to, because I have negative 0.85 t squared, I would prefer to have that as a positive because positive numbers are easier to deal with. So I'm just going to add to both sides 0.85 t squared in order for it to cancel off. So negative 0.85 t squared plus 2 plus 0.85 t squared. So that cancels it off on that side. So I end up with 0.85 t squared equals 2. And then I'm going to divide both sides by 0.85 in order to isolate for t, because I'm multiplying it by 0.85. In order to get rid of my, because t squared is what 2 divided by 0.85 is equal to, I'm going to take the square root of both sides in order to figure out what t is equal to. So t is going to be equal to the square root of 2 divided by 0.85. And if we put that into our calculator, we get 1.66. So now I have to figure out, what does that answer? What does that number mean? So our question was, how long will the skateboarder be in the air? Our time equals 1.66. So we hit the ground at 1.66. So the skateboarder will be in the air for 1.66 seconds. That's how we answer that. So looking at our question, what information we have, what tools we can use, and then making sure that we answered our question by looking back at what our question is asking, and writing a sentence helps us know that what we've answered are useful. Okay, question 2. Janet borrowed $2,300 at 10% per year, compounded quarterly. Part A, how much must she repay after 5 years? Okay, so we have to figure out what information is this, what is this relating to? So we have, our question says that we're borrowing money and we're compounding it quarterly. So that means that we're talking about compound interest. So we know that we need to use the formula A equals P times 1 plus R over N all to the exponent NT. Because this is a question that we're doing something about money with compounding, that you need to use this formula. And we need to figure out what do we know and what don't we know and what we're looking for to figure out how to progress with our question. So Janet borrowed $2,300. So that's our principal. That's what we're starting with, $2,300 at 10% per year. So our rate is 10%, which is equal to 0.1. Compounded quarterly. So our N is 4 because quarterly is 4. And then it says, how much must she repay after 5 years? So our time is 5 years. So how much she needs to repay is our amount at the end. So that's what we're looking for. So then we substitute our numbers into our formula. So we have 2,300 times 1 plus 0.1 divided by 4, all to the exponent 4 times 5. So we're going to simplify that as much as we can. So 0.1 divided by 4 plus 1 is equal to 1.025. And 4 times 5 is equal to 20. So we end up with 2,300 times 1.025 to the exponent 20. So we need to figure out what that is. We use our scientific calculator to do 1.025 to the exponent 20 times 2,300. And we end up with 3,700 So now I'm going to figure out, does this answer our question? How much must you pay after 5 years? So she must pay $3,768.82 after 5 years. So yes, that does answer a question. That makes sense. So then part B, how much of the amount she pays is interest? So we figure out our interest by taking the amount that we totally pay, our full amount, take away our principal, which is how much we borrowed. So our total amount we calculated is $3,768.82. Take away our principal, which is $2,300. So this is going to equal $1,468.82. So the interest she repays is $1,468.82. Okay, so that's how we attack a problem like this. So we need to figure out, as always, what the question's asking, what tools we have, and then what information we know, what we're looking for, and then did we actually answer the question? Question 3, consider the powers 64 squared and 16 cubed. Are these powers the same? Use the exponent rules to explain. Okay, so this is a little bit different than what we've done before. So we're trying to figure out if 64 squared equals 16 cubed. That's what the question's asking. Are these powers the same? So they don't look the same. We could calculate, we could just use a calculator, and then we could figure out if they actually are equal. We could calculate what 64 squared is and what 16 cubed is. But the question asks us to use the exponent rules to explain. So we need to use them to figure out if these are the same. We can get these to look the same. So I'm going to think about 64 squared first. And I know that 64 is 8 squared. So I'm going to change my 64 to a base of 8 squared. And then I still want that to be squared because it's a power of a power, right? Okay, so then I'm going to think about 16 cubed. Now, 16 is 2 times 8, but I can't get 16 to be a base of 8 with whole numbers. So 8 to the exponent something as a whole number does not equal 16. So that doesn't help me. But I do know that 4 squared is equal to 16. So I can change my base to 4 squared. Okay. So then, 8 is 2 times 4, but I can't get 8 to be a base of 4. 4 to the exponent, nothing. No whole number is equal to 8. But let's see, can I think of, well, 2 to the exponent 3 is equal to 8. So then that's still squared, and that's still all squared, right? Because this is this squared and this is this squared. So then let's see. So let's simplify that because that's getting pretty ugly. So this is a power of a power rule. It's actually a power of a power of a power, but I can still, so I'm going to multiply my exponents. So I now have my base is 2, and I'm going to do 3 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12. So 2 to the exponent 12 is the same as 64 to the exponent 2. That's what we figured out so far. Okay. So then 16 cubed we have is 4 squared to the exponent 3. Well, can we get 4 to the base of 2? Because that's what we were able to get 64 to the base of 2. So I'm going to say, okay, well, 2 squared I know is 4. So then I have 2 squared to the exponent 2, and then to the exponent 3. Again, this is messy, so let's figure out, okay, so this is power of power of power. So we're going to do 2 to the exponent 2 times 2 times 3. Okay, well, 2 to the exponent, 2 times 2 is 4. 4 times 3 is 12. So 2 to the exponent 12. So are our powers the same? Yes, they are the same because we can reduce them both to be 2 to the exponent 12. 64 to the exponent 2 is equal to 2 to the exponent 12. And 16 to the exponent 3 is equal to 2 to the exponent 12. So therefore, yes, we need to answer the question. They are the same. As both. So as 64 squared is equal to 2 to the exponent 12, and 16 cubed is equal to 2 to the exponent 12. And that's how you answer a question that is asking you to use exponent rules to justify if two powers are the same. You're trying to reduce them to see if you can get them, or increase them to get them to be at the same base, and then see if they have the same base and exponents once you're through. Okay, question 4. Graph the relation, then represent it with an equation in the form y equals a times x minus h squared plus k. So because I see that this has y equals a times x minus h squared plus k, that makes me think of quadratic transformations, about the shifting things around. So I'm going to think about that. Probably I'm going to be using that information where we're shifting, where we had our a, h, and k, were helping us to know our opening and our shifting of our parabola. But this question, we're doing it a little bit differently than how we were doing it before. Usually we were given our formula and we would draw it and then figure out our drawing from our formula. This time we're going to figure out our drawing from a table of values, and then we're going to use that to figure out what our equation is. So our table of values, we have -3 and 1 is our first point. -2 and 4 is our second point. -1 and 5 is our third point. 0 and 4 is our fourth point. 1 and 1 is our fifth point. And 2 and -4 is our sixth point. Okay, so now we have a piece of our parabola. So we can roughly connect our dots. As we know, it can be really difficult to draw parabolas perfectly, and that is fine. And this gives me a rough idea of what it's going to look like. So looking at this parabola, let's see if we can figure out what our a, h, and k are. So a, well, our parabola opens down, but it doesn't look stretched or compressed, so we don't need to worry about that because we don't have those tools. But because it's looking down, it's going to be -1. Because it's opening down, a is going to be -1. H, well, our parabola has shifted to, our vertex has shifted over to -1. So we've shifted left. And so by 1, so our h is -1. And our k, we've shifted our vertex. We can see it has shifted up 5. So that means that our k is +5. So our formula, so y equals a times x minus h squared plus k is equal to, so a is now -1, x is still x, h is -1, but we're doing x minus h, so x minus -1 is going to be x plus 1, right? And then k is +5, so plus k is +5. So we end up with y equals -1 times x plus 1 all squared plus 5. And that is our equation. So let's see, would we answer the question? Graph the relation? Yes, we did. Then represent it with an equation. That's what we did. Okay, perfect. Number 5, to save for a motorcycle, Abdul deposited $2,000 into an account that earned simple interest at 5.4% per year. How much more would the investment earn in 3 years if it were invested at 5.4% compounded annually? Okay, so this question says simple interest first. So Abdul first deposited a amount of money in for simple interest, but the question is wondering is how much more would he earn if he did it compounded? So I can tell that I need to figure out both the simple interest because I need to find out how much he earned for simple interest and compare it to how much he earned through compound interest. So there's going to be a few steps for this one. So I like to organize my information to be really, really clear that what I am doing, both so that I can keep track of it, but also so that whoever I'm handing it in, if I'm handing my work into someone, that they can understand it as well. So for simple interest, we know that's I equals PRT. So we need to figure out I is what we're looking for. P is our principal, which is $2,000. R is our rate, which is 5.4%, which is equal to 0.54. Sorry, I did that wrong. It's really, really easy to mess up when we're converting to decimal. So our rate is 5.4%, which is equal to 0.054. And then our time, earning it in 3 years, is 3. Okay, so this is going to equal to, so we're going to substitute our values into our I equals PRT. So we have 2,000 times 0.054 times 3. And then we're going to calculate that on our hand calculator. As always, you can use whatever calculator you have. It's best to get comfortable with the one you're going to be using for your exam. So that equals $324. So with simple interest, Abdul earns $324. So I'm just going to write a sentence so that I know what that number means. Abdul earned $324 through simple interest. Again, just so that I can keep track of what my random numbers are, so they don't seem so random. Okay, does that answer the question? No, we're looking for how much more. So now we need to figure out how much you would earn if you compounded it annually over 3 years. And then we would go from there. So we're going to do compound interest. We're going to compare. So compound interest is A equals P times 1 plus R over N all to the exponent NT. A is our amount, what we're looking for. So 2,000. R is equal to 5.4%, which is equal to 0.054. Our N is equal to, we're compounding it annually, so our N is equal to 1. And our T is still 3. We're still doing it for 3 years. Okay, so now we substitute our values in. So we have 2,000 times 1 plus 0.054 over 1, all to the exponent 1 times 3. So then we have 2,000 times 1.054 to the exponent 3. So you can see our values are not too different from in between our simple interest and our compound interest, because we're just compounding it once per year, but we're going to see how much of a difference that still makes. So we have 2,000 times 1.054 to the exponent 3 equals $2,341.81. Okay, so that seems like a lot more, right? We have $2,341.81 compared to $324. But do we get the same information? When we are doing compound interest, this tells us how much money we have in total at the end. So in order to find the interest earned, we need to do our amount, take away our principal. So we need to do $2,341.81, take away 2,000. So that means $341.81 is what our interest is. So Abdul would earn $341.81 in interest. Compounding. So what does our question ask? How much more would the investment earn in 3 years if it was invested at compounding? So we still haven't answered the question. We want to know how much more. So how much more? This is why organizing our information can be really, really helpful. So I'm now writing all over the screen, but hopefully you can follow it. So how much more? So we have $341.81, take away 324 to figure out the difference, to figure out how much more. So $341.81, take away 324 is equal to $17.81. So he would earn $17.81 more. And now we finally answered the question. Okay, let's keep going. Question number 6, write an expression in simplified form for the area of this shape. So we have sort of an L type, generally rectangle, but it's an L shape opposed to just a straight rectangle. And we have one dimension is x plus 5. And then we have the long part of the short part of the L, the top of the L is x squared plus 3. Then the next part of the L is x plus 3. And the other part of the L is 2x plus 1. Just listening to this, you can't, it's really difficult to visualize. So in order to figure out the area of this total shape, I don't know what the area, there's no formula for an area of an L, but there is a formula for rectangles. So what I'm going to do is I'm going to break this up into 2 rectangles that are easier for me to find out. So I'm going to call them rectangle A and rectangle B. And I know that if I add rectangle A and B together, that's going to give me the area of the entire shape. So first, the area of rectangle A. Rectangle area is length times width. So I have x plus 3 times 2x plus 1. Okay, so now I have 2 binomials I can see that are multiplying by each other, so I need to expand them. So I can use my algebra tiles or box method or FOIL if that works for you, or even just writing them each out. So we can do x times 2x plus x times 1 plus 3 times 2x plus 3 times 1. So then x times 2x is 2x squared. And then we have 1x plus 3 times 2x is 6x. So we have 7 x's plus 3. Okay, so the area of rectangle A can be represented by 2x squared plus 7x plus 3. Great. Now we're going to find the area of rectangle B. So here, looking at rectangle B, we have one dimension is x plus 5, but our other dimension, we don't have the full length of the area of the full length of the side. We have 2 plus 3 is part of it, but we're missing part of it. That is only part of that side. So we actually need 2 plus 3, but we know that the end of that is 2x plus 1. So we need to add those two together to figure out the full length. So 2x plus 2x is 4x, 3 plus 1 is 4. So one of our dimensions of our rectangle B is 4x plus 4. So now we're going to multiply our two sides to find the area for rectangle B. So we have x plus 5 times 4x plus 4. Again, you can use algebra tiles, the box method, or other tool that we have. I'm going to write it out the same way that I did before. So I have x times 4x plus x times 4 plus 5 times 4x plus 5 times 4. So then we're going to multiply that out and simplify. So x times 4x is 4x squared. X times 4 is 4x. 5 times 4x is 20x. So add those two together because they're like terms. We have 20x. Sorry, 24x is what I should have written. 4x plus 20x is equal to 24x. Is our second term. And then our third term is 5 times 4, which is 20. Great. So we now have the area A and the area B. So our total area is equal to the area of A plus the area of B, which is equal to, we're going to take our two simplified areas and add them together. So we have 2x squared plus 7x plus 3 plus 4x squared plus 24x plus 20. So then we're going to add our like terms together. So 2x squared plus 4x squared, and then 7x plus 24x plus 3 plus 20. Don't mind my cat. She's just telling us that she has found one of my kids' toys and has caught it. So we have 2x squared plus 4x squared is 6x squared. 7x plus 24x is equal to 31x. And then 3 plus 20 is 23. And there we go. That's our simplified expression that would represent this area of the shape. As you can see, throughout these things, sometimes we're adding and subtracting or multiplying or even dividing. So using the mental math activities we do at the beginning of each lesson is how they can be useful in this when we're doing our other problems. All right, question 7. We're getting through all the things that we've been learning. The population of Kenora District P is projected to grow until 2050 based on the relation P equals 65,533 times 1.029 to the exponent n, where n is the number of years after 2016. So first, part A, sketch a graph of this relation. This is made up numbers. I don't know exactly what this actually be. So to sketch a graph of this relation, I'm going to make a table of values where I'm going to compare my n number of years to my p. So when my n is 0, so it's 0 years after 2016, my p would be 65,533 times 1.09, 1.029 to the exponent 0. I know that any number to the exponent 0 is 1, so that's just going to equal 65,533. Now, if my p was 1, then I would replace my exponent with 1. So then I'm going to have 65,533 times 1.029 to the exponent 1. So then I'm going to have 65,533 times 1.029, which is equal to 67,433. This is going to give me a decimal because we're talking about population, I'm just going to use whole numbers and round my answers because we have whole people, we don't have part people. Okay, when n is 2, so we're 2 years after 2016. So as you can see, we want to go up to 2050 probably. So I'm gonna actually, instead of doing 2, I'm gonna jump and I'm gonna say, okay, well, what happens if n is equal to 10? Because that might be more useful for me. So I'm gonna put 10 in for my exponent. So I have 65,533 times 1.012 to the exponent 10. We can pick any values of n and go from there. So then I have 87,219. So then I'm going to say, now I'm going to say 20 years after 2016. So we have 65,533 times 1.029 to the exponent 20 equals. So as you can see, this can be a little bit tedious to do it all by hand, and why we often use computers or graphing calculators, but we can do it by hand. So we have 116,083. And then we're going to do 30, if n was 30. So we have 65,533 times 1.029 times to the exponent 30. So if we had done this just by ones, it would take a long, long time to get up to where we need to be. So we need to pick values that are useful for us. So we now have 154,497. Okay, so now to sketch this relation, I'm going to be doing my n is my horizontal axis, my number of years is my horizontal axis, and p, my population, is my vertical axis. So here, in order to figure out what is useful, I'm just going to go up by my horizontal axis. I'm just going to go up by ones. That's going to be fine. And my vertical axis, because I need to go up to 154,000, I'm going to go up by 50,000. Vertical scale. So you can decide what would make sense for you. And again, we're sketching it, so it's going to be, doesn't have to be perfectly precise. So at 0 years, we're at 65,000. So then that's going to be roughly here at 65,000, my vertical axis, and 0. At 1, that was going to be at 67,000. So again, roughly here, pretty close. So that's why we jump to 10 is going to be 87,000. So that's going to be roughly here. 20 was 116,000. So that's going to be roughly here. And 30 is 154,000. So that's going to be roughly here. So then we can see our gradual growth, and we can continue our line roughly like that. So what does a p-intercept? So that's part A, we've graphed it. What does the p-intercept mean? P-intercept is where our population was 0, or sorry, our population hadn't changed from 2000. So it represents the population in 2016. And that's what the answer to that question. All right, so we are at the end of our time today. So we don't have time to finish the last few questions that we have, but we are halfway through Unit 2. So if you want to submit lessons 6 through 8 for marking, feel free. That would be great. Remember, the key questions are the ones marked with the key icon, and they're the ones to submit. Do all of them and show all of your work. As always, if you have any questions, please contact me at by calling me and leaving a message at the office, or emailing me at bronwyn.slate@nnec.on.ca, or Facebooking me at bslatewasa. I hope you have a lovely Family Day weekend, and we will see you on Tuesday. Miigwech.